In this video, I will talk about sol-gel synthesis and hydrothermal or solvothermal synthesis methods. To synthesize nanoparticles, we prefer to use sol-gel and hydrothermal or solvothermal synthesis methods. And firstly, I will explain the sol-gel method. Sol-gel method is a wet chemical technique. Colloidal solution is called a sol and gradually transforms into a solid network which is called as gel. So we have sol and gel. Sol is the colloidal solution and gel is the solid network. And this process relies on hydrolysis and condensation reactions of metal precursors to form a 3D oxide network. And in sol-gel process, we have 4 steps. And these steps are preparation of sol. The second step is condensation. The third step is gelation. And fourth step is drying and calcination. So in the first step, a metal precursor is dissolved in solvents such as ethanol or methanol. So we need a precursor and a solvent, ethanol or methanol. And in this step, controlled hydrolysis breaks metal alkoxide bonds and forms metal OH bonds. So we have metal OH bond formation here. In the second step, this formed metal oxides, metal hydroxides, bonds, hydrolysis, metal or oxygen metal bonds forms. So this is simply a hydrolysis reaction, and this process releases water or an alcohol. And this process produces growing oxide network. So at the end we will have a oxide network, which is something like this, right? And we have a gelation process, and the sol gradually thickens and becomes a gel, a continuous solid network containing solvent within the pores. We create a gel due to the process, so it takes time. After the gelation, the gel is dried to remove the solvent. So we remove the solvent in this step and then calcinate the sample to remove the organic residues and crystallize the nanoparticles. So we will have a crystallization also in this process. I want to talk about hydrothermal or solvothermal synthesis. Solvothermal or the hydrolysis, hydrothermal synthesis reaction occurs in a sealed autoclave under high temperature and pressure. So what is autoclave? We use an autoclave, and these are generally Teflon lined autoclave. And these autoclaves, we have a Teflon container. These are generally between 50 milliliter to 250 milliliters. This is the volume. We have a lid of the Teflon line. So this is completed Teflon. This red thing is Teflon. And we put it a stainless steel another container, and it also has a lid. So we have a lid, and this Teflon container fits it perfectly to this stainless steel part. And we can heat this autoclave in an oven around 200 C. If you heat too much, of course, the autoclave can explode. But this is another part. So we have again 4 steps for this process. So the first step is precursor solution preparation. And metal salts or metal organic compounds are dissolved in water or an organic solvent. So if we use water, for instance, it is called as hydrothermal synthesis. If we use an organic solvent, then we call it we call the process as solvothermal synthesis. So this is the naming of this method. So after the precursor solution preparation, we put the solution in a autoclave. So we will put the solution into autoclave and we heat the autoclave under an oven. So this temperature depends on the synthesized nanoparticles, of course, but we prefer to use around 100 to 200 Celsius. So it depends on the condition and of course the material. Then is the fourth step. So this process can take around 24 hours to, for instance, 4 hours. It depends on the reaction, of course. And in the first step, we cool and wash the product. So this product does not need a calcination. And after the cooling, the solid product is collected and you can use your nanoparticles. And I want to talk about the advantages and disadvantages. So firstly, I want to write the advantages of hydrothermal synthesis or solvothermal, which is the same thing, I guess. So the first advantage is that products are highly crystalline nanoparticles without calcination. So we have very high crystallization in hydrothermal synthesis. And this synthesis allows control over morphology by adjusting temperature, pressure, and solvent polarity. So we can control the morphology. The disadvantage of this hydrothermal or the solvothermal method is it is not ideal for large scale production. I was synthesizing, this is my experience, zinc oxide nanoflowers, and I was using 200 milliliters of Teflon lined autoclave. So this was my autoclave size. And at the end of the process, I could synthesize about 1.5 gram of zinc oxide nanoflower. So, and this process takes time. It takes around 2 days. I'm preparing the precursor solution, and this preparation takes around 4 hours. After 4 hours, I put it to the autoclave and it takes 24 hours. I cool it, and at the end of the 2 days, I could just synthesize 1.5 grams of zinc oxide nanoflower. So it is not an easy process, but this is the situation. And the second thing, I want to talk about the advantages and disadvantages of sol gel method. So the so maybe I can write here sol gel method. Sol gel method. And the advantage of the sol gel method, you can obtain excellent chemical homogeneity and you can also control over the composition. So chemical homogeneity plus you can control the composition. And this method is suitable for thin films, coatings and powders. And we have some, of course, disadvantages. The issue of the Soljan method is that it is hard to control particle size without additives, so you may need some adjustments to control the particle size, but it will not be easy. So we have an issue on hard to control particle size without additives.